Hello and welcome back to the channel Science, Maths and Engineering. Today we are going to solve the fourth part of this mechanical engineering paper, the examination for which was conducted by the Directorate of Technical Education Assam for the post of Assistant Professor in 2020. Now, as we have already discussed, all these questions of this paper are from previous year GATE question papers, and a pie chart is shown to give us the information of the number of questions that came from each year. So let's get started. In a CAD package, a mirror image of a 2D point P 5,10 is to be obtained about a line which passes through the origin and makes an angle of 45 degree counterclockwise with the x-axis. The coordinates of the transform point will be, so the answer is, so see, this is the xy plane and we have this line that is making an angle 45 degree and passing through the origin. So as it is making 45 degrees, so slope is m is 45 degree, tan 45 degree, there is the slope, so m is 1. So our equation becomes y equal to mx plus c, that is y equal to x plus c. Now as it passes to the origin, so c is 0, so we have y equal to x. Now this is the point P and it will be reflected to this point P dash x comma y, and this is the mirror which is given by y equal to x. Now this line P dash would be perpendicular to this line y equal to x, as P dash is the mirror image of P. So the slope of this line P dash would be equal to minus of 1 by m, as m into m1 is equal to minus 1. There is the product of the slope of two perpendicular lines is minus 1. So from here we get m1 is equal to minus of 1. Now the equation for this line P dash is y equal to m1x plus b. Now m1 is minus 1, so it is equal to minus of x plus b. Now if we see that this point P is a point on this line P dash, so it will satisfy this equation y equal to minus of x plus b. So we have 10 is equal to minus of 5 plus b. So from here we get b is equal to 15. So equation becomes y is equal to minus of x plus 15. Again q, this point q, there is the intersection of these two lines y equal to x and y equal to minus of x plus 15. So this will satisfy both these equations. So what we have, that if q is defined by q coordinates are x1 comma y1, so we have y1 is equal to x1 from this line equation and y1 is equal to minus of x1 plus 15 from this equation. So from here we get x1 is equal to 7.5 and y1 equal to 7.5. Okay. Again, as this is the P is the P dash is the mirror image of P, so this PQ would be equal to P dash Q. As we know, in mirror, if we have a mirror image, then it will be also at the same distance, okay, from the mirror. This reflection and the original object will be at the same distance from the mirror. So from here we get that x1 would be equal to 5 plus x by 2 and y1 would be equal to 10 plus y by 2. You see midpoint theorem. So here we can get this. So from here we get that y is equal to 5 and x is equal to 10. So our answer is P dash, so coordinate of P dash is 10, 5. Now in any case we could have done this much more easily if we remember this thing, that as this line is passing through the origin at an angle of 45 degree, so if this coordinate of P is x comma y, then the coordinate of P dash would be y comma x. Now it is 5 comma 10, and see we got the coordinate of the mirror image at 10 comma 5. Had it been 4 comma 8, it would have been 8 comma 4. Had it been 3 comma 4, it would have been 4 comma 3. So that is a simpler way we can remember it. So next question. Better surface finish is obtained when a large rake angle because the answer is C. A large rake angle leads to a better surface finish in machining operations. Now the shear angle increases in case of a large rake angle and it makes the chip thinner. As the chip is thinner, so heat accumulation gets decreases and it reduces the friction, and thus it results in smoother cutting action and higher quality of the surface finish. Okay. So next question. The cross sections of two solid bars made of the same material as shown in the figure is given. The square cross section has flexural rigidity I1, while the circular cross section has a flexural rigidity of I2, and both sections have the same cross sectional area. So the ratio I1 by I2 is to be determined. So let us see. See, flexural rigidity is given by EI. Now here E1 is equal to E2 as this same material is used. So next, if we see, we take the radius of the circle be smaller and the side of each side, length of each side of the square be small a. Now as the area of the circle is equal to area of the square, so we get a square is equal to pi into r square. So from here, this is just one equation, and then if we see I1 would be equal to BD cube by 12, so it is B is a, D is also a, so it is a to the 4 by 12. I2 is equal to pi by 64 into d to the power 4, which is equal to pi by 4 into r to the power 4. Now E1 I1 by E2 I2, that is the ratio of this flexural rigidity, E1 I1 divided by E2 I2 becomes I1 by I2, which is equal to a to the power 4 by 12 divided by pi by 4 r to the power 12, r to the power 4, sorry. So it becomes a to the power 4 by 12 into 4 by pi r to the power 4. So 4 and 12, so it is 1 by 3 remains, a to the power 4 remains, and here pi into r to the power 4. Now 1 by 3 pi into a to the power 4 can be given as pi r square to the power whole square. So it becomes pi square r to the power 4. From here we get this ratio is pi by 3. So next question. The main cutting force acting on a drill during the turning operation of a metal is 400 Newton. The turning was performed using 2 mm depth of cut and 0.1 mm per revolution feed rate. So the specific cutting pressure in Newton per millimeter square is, so the answer is C. Cutting area per revolution is W into T. So it is 2 into 0.1 millimeter square, which becomes 0.2 millimeter square. Now specific cutting pressure would be equal to force by area, so it becomes 400 divided by 0.2, that is 2000 Newton per millimeter square. Next question. A mass M is attached to two identical springs having spring constant K as shown in the figure. The natural frequency omega of this single degree of freedom system is, so the answer is C. These two are in parallel, so our equivalent K would be equal to K plus K, that is twice K. Now omega n would be given by root over K of equivalent divided by M, so it becomes root over 2K by M. So option B. Next question. Consider the turbulent flow of a fluid through a circular pipe of diameter capital D. Identify the correct pair of statements. 1. The fluid is well mixed. 2. The fluid is unmixed. 3. Reynolds number less than 2300. Reynolds number greater than 2300. Option 4. So the answer is C. Now this is a turbulent flow, so it will be a well mixed flow. So our one is correct. Then turbulent flow through a circular pipe occurs at Reynolds number greater than 2300. So our this option 1 and option 4 are correct. So it is given in option C, that 1 and 4. So our correct pair of statements is 1 and 4. So option C. Next question. Holes of diameter 25, upper limit of plus 0.040 and lower limit of plus 0.020 millimeter are assembled interchangeably with the pins of diameter 25, upper limit of plus 0.005 and lower limit of minus 0.008 millimeter. The minimum clearance in the assembly will be, so the answer is the minimum diameter of the hole we can find, that is 25 plus 0.020, that is 25.020 millimeter, and the maximum diameter of the shaft is 25.0 plus 0.005, that is 25.005 millimeter. So the minimum clearance in millimeter between the hole and the shaft would be equal to what? Minimum diameter of the hole minus maximum diameter of the shaft, which is equal to 0.015 millimeter or 15 micron. Next question. A body of mass capital M, which is given as 10 kg, is initially stationary on a 45-degree inclined plane as shown in the figure. The coefficient of dynamic friction between the body and the plane is 0.5. The body slides down the plane and attains a velocity of 20 meter per second. The distance traveled in meter by the body along the plane is. So this is a simple problem of engineering mechanics. So the answer is, see, this is the body with mass m. Now it has a weight of mg acting downwards. Now here, as this angle is 45 degree, this angle is also 45 degree. So we can prove it through geometry if we want. Then see, f, this is the mass m, so it will have this perpendicular to the surface, it will have this 1 mg cos theta, and the reaction would be perpendicular here, so r would be equal to mg cos theta. Next, frictional, as this is coming downward, the frictional force is along the upward direction along the plane, and it is f equal to mu r. Okay, then this acceleration along this slide downwards is mg sin theta. So if we see frictional force, we have f equal to mu r, so that is f equal to mu into mg cos theta. Force along the slope is mg sin theta. So net force is what? It is mg sin theta minus mu mg cos theta, right? This force minus the frictional force. Now acceleration would be how much? It will be equal to f net divided by m. So it is acceleration is a is equal to z sin theta minus mu g cos theta. Now we have acceleration. Initial velocity was 0 and distance we need to determine. So s is equal to then v square minus u square by twice a. So from here we get v square is 20. So 20 square divided by 2 into g, that is 9.81 into sin theta minus mu cos theta. Now sin of theta is 45. So sin of 45 minus 0.5 is the mu and cos of 45. So from here we get our capital S is 57.76 meter. So next question. Three parallel pipes connected at the two ends have flow rates Q1, Q2 and Q3 respectively, and the corresponding frictional head losses are HL1, HL2 and HL3 respectively. So the correct expression for the total flow rate and the frictional head loss across the two ends are, so the answer is C. Here the two ends are common, Q1, Q2 and Q3. Along this flow goes. So our total flow at the inlet or outlet would be equal to what? Q would be equal to Q1 plus Q2 plus Q3. Then the frictional head losses would be again equal. So our HL would be equal to HL1 plus HL2 plus HL3. So next question. Which one of the following modifications of the simple ideal Rankine cycle increases the thermal efficiency and reduces the moisture content of the steam at the turbine outlet? So the answer is C. If we increase the turbine inlet temperature, then what happens? It increases the temperature of superheat of the steam, and so it increases the thermal efficiency and also reduces the moisture content of the steam at the turbine outlet. Now if we increase the boiler pressure, what happens is that the efficiency of the boiler increases up to a maximum of 166 bar, and the efficiency decreases after that, and there is no change in the moisture content of the steam at the turbine outlet. Next, if we decrease the boiler pressure, so what happens is that decreasing the boiler pressure decreases the boiler efficiency, and there is no change in the moisture content of the steam at the turbine outlet. Next, if we decrease the condenser pressure, what happens is that the boiler efficiency increases, but it also increases the moisture content of the steam at the turbine outlet. So our option A, that is increasing the turbine inlet temperature, increases the thermal efficiency and reduces the moisture content, is the correct option. So next question. The damping ratio for a viscously damped spring mass system governed by the relationship m into d2x by dt square plus c into dx by dt plus kx is equal to f of t is given by, so the answer is C. For this equation, we have zeta is equal to, that is damping ratio is equal to C by Cc. Now Cc is equal to 2m omega n, this will be omega n, so it is equal to 2m root over k by m, so that is 2 root km. So zeta would be equal to C divided by 2 root km. Next question. The volumetric flow rate per unit depth between two streamlines having stream functions psi 1 and psi 2 is, so it is given by modulus of psi 1 minus psi 2. Next question. A plastic sleeve of outer radius R0 is equal to 1 millimeter covers a wire radius of 0.5 millimeter carrying electric current. Okay, so the thermal conductivity of the plastic is given. The heat transfer coefficient on the outer surface of the sleeve is given. Now, if we add more plastic cover, the heat transfer from the wire to the ambient will increase, decrease, or remain the same, or will be zero. The answer is C. We know R0, we know Ri, we know K, and we know H. Now, critical R0 would be equal to K by H, so which is equal to 6 millimeter. So, this critical R0 is greater than our current R0. Okay. So, as this is the heat transfer from this wire to the ambient will, therefore what, it will increase till we reach the R0 is equal to R0 of critical, that is till we reach 6 millimeter, the heat transfer will increase, and after that only it will decrease. Okay, so our answer is that the heat transfer will increase. So next question. The Blasius equation related to a boundary layer theory is a, so we need to find out whether it is a which order, third order or second order, whether it is linear or non-linear, whether it is partial differential equation or ordinary differential equation. So let us see. See, the Blasius equation related to the boundary layer theory is given by f triple dash eta plus half of f of eta into f double dash eta is equal to 0. Now, as this product is there, so it is non-linear. Then, as it is triple dash, so it is 3 times differentiated, so it is a third order. Then this is again an ordinary differential equation. So our equation is a third order non-linear ordinary differential equation. Next question. In a casting process, a vertical channel through which molten metal flows downward from the pouring basin to runner for reaching the mold cavity is called, so it is known as sprue. Next question. A metal ball of diameter 60 millimeter is initially at 220 degrees centigrade. The ball is suddenly cooled by an air jet of 20 degrees centigrade. The heat transfer coefficient is 200 watt per meter square Kelvin. The specific heat, thermal conductivity and density of the metal ball are 400 joule per kg Kelvin, 400 watt per meter Kelvin and 9000 kg per meter cube respectively. The ball temperature in degree centigrade after 90 seconds will be approximately. So see, the given system is solved by using this Lamb capacitance method. So we have this equation T minus T infinity divided by Ti minus T infinity is equal to e to the power minus HA divided by rho Vc into T, where T is the temperature of the ball after small t seconds, T infinity is the temperature of the surrounding temperature, Ti is the temperature of the metal, rho is the density of the metal, H is the convective heat transfer coefficient, capital C is the specific heat of the metal, A is the area, capital V is the volume, and small t is the time. So from here we can see A by V, we can determine it is 100 as it is a sphere. So you can find it is 3 by R, so it becomes 100. So if we put all these values here, we can find the value of T, which is equal to 141 degrees centigrade. Next question. A helical spring has spring constant K, small k. If the wire diameter, spring diameter and the number of coils are all doubled, then the spring constant of the new spring becomes, the answer is, see, spring constant is given by capital Z into small d to the power 4 divided by 8 into capital D cube n, small n. Capital Z is the modulus of rigidity, small d is the wire diameter, capital D is the mean diameter of the coil, and small n is the number of active coils. So our K1 becomes this equation and K2 becomes this equation from this equation. Okay. Next, we have D2 is equal to twice of D1, capital D2 is equal to 2 of capital D1 and N2 is equal to 2 of N1. So once we put these values, you can see that K2 is equal to K1. So our new spring constant is K2 is equal to K1, which is K. So our option A is the correct answer. Next, a force P is applied at a distance x from the end of the beam as shown in the figure. what would be the value of x so that the displacement at A is equal to 0? So let us see. See, here we have this equation and we have this figure and we have this force P. Now we can shift this force here by using a force, and by shifting this we can shift this force by using a moment. So how it is done is that here it is a force P. We can assume that we have a force equal and opposite force P here at this end. Now this one and this below one, they will form a couple. So we have this force image and this couple is a moment, so it is equal to P into this distance L minus X. Okay, so now force is here or force is here, it is the same. So this is represented by this figure. So we have this force at A and this moment M. Now because of this force P, it is going down, and because of this moment M, it is going up. Now because of this force, the delta 1 is equal to PL cube divided by 3EI, and because of this moment, this deflection would be delta 2 is equal to ml square divided by 2EI. Now these two has to balance each other so that our displacement of A is 0. So delta 1 is equal to delta 2. So we have PL cube divided by 3EI is equal to m into L square divided by 2EI. EI gets cancelled, L cube and L square, so L square gets cancelled. Here only PL remains, so PL by 3 is equal to m by 2 only. Now what is m? M is P into L minus X. From here we can get X is equal to 0.33 L. So next question. The number of qualitatively distinct kinematic inversions possible for a Grashof chain with 4 revolute pairs is, so the answer is that the number of qualitative distinctly kinematic inversions possible for a Grashof chain with 4 revolute pairs is 3, and these are crank rocker mechanism, double rocker mechanism, and double crank mechanism. So next question. The coal forming process in which a hardened tool is pressed against a workpiece, and the workpiece, that is when there is a relative motion between the tool and the workpiece, to produce a roughened surface with a regular pattern is, so the answer is C. What we are being asked is this: how do we make this regular rough surface, okay, in a tool? Now if we see any filing tool or most of these hand tools, if we see in the handle there are some regular patterns, and this is very rough. So this is for the effective gripping of the surface. Okay, so when we operate, so it should not slip, so it's for gripping. Now this is done by this process called knurling. Okay, so here what happens, this hardened tools is pressed against the workpiece and this roughened surface with regular pattern is obtained. So with this we have come to an end of this part 4 of this paper. So we'll soon come with the part 5. So stay tuned with the channel and see you in the next one.